Okay, here we go. Let's see, we got 41 to 43 uses this table down here. Um, so let's look at this. Choose at random a young child 19 to 22, ask their age and where they live, their parents, their own place, or some other place such as a dorm. Here's the model, probability model for the 12 possible answers. So you've got your age, and then depending on what their age is, they could live with their parents, their own place, or other. We've got all of these. Okay, so 41. Why is this a legitimate discrete probability model? Well, remember, to be a discrete means there's a finite number. Well, since there's a finite number of possible um, ages and locations of living, that's a discrete population or a discrete sample. It's a legitimate model. Well, all of these individual ones are between 0 and 1, and they all add up. If you add them all up, they all add up to a total of 1. Okay, so that's why it is. Okay, so they all add up to 1, and each probability is between 0 and 1. Okay, what's the probability the person chosen is a 19-year-old who lives in his or her own place? 4%. What's the probability the person is 19 years old? Well, 19 years old, are all of these people here. So 11 plus 4 is 15 plus 3 is 18%. Right? What's the probability that person chooses lives in his or her own place? His or her own place are all of those people right there, right? And what is that? 4 plus 9 is 13, plus 13 is 26, plus 16 is 42%. Does that make sense? That total right there is there. Okay, 42. List the outcomes that make up the event. A is a person chosen, let me erase this here, is either 19 or lives in his or her own place or both. So list the outcomes. They're either 19 or lives in his or her own place, or both is the one that's circled both times. Okay, so there's all of the outcomes, and if we want to list them, A would be 19 with parents, 19 with own place, 19 other, 20 with own place, 21 with own place, and 22 with own place. Those are all the 1, 2, 3, 4, 5, 6 different outcomes or different possibilities that could be in event A. What's the probability of A? Okay, probability of A is 0.11 plus 0.04 plus 0.03 plus 0.09 plus 0.13 plus 0.16, which is that 15, 18, plus 9 is 27, 40, 56. 0.56 or 56%. Why is this not the sum of all of these added together, right? Why is it not the sum of the probabilities I found in part C and D above? 19 years old and his or her own place, because isn't this 19 and his or her own? Why is that not B? 18 plus 42 is 60%. why do these two not match? Question mark. Well, if you look at this, if I add, this is a probability that you're 19, and this is a probability that you own your own place. If you're 19, you add these up together. If you add your own, you add these up. What did I add twice? Exactly, 0.04. So if I added 0.04 twice, so if I take one of them out, what's 60% minus 4? Exactly right, 56%. So that's why, because I added the 0.04 twice, which is, the probability that you're in 19 and not probability that you're, the probability that you're 19 and own is in both of those, or not probability. If you're 19 or if you own your own, you're in both of those categories. Okay, 43. What is the probability the person chosen is 21 or older? Probability that you're greater, that the person, let's call him X, is greater than or equal to 21. Okay, let's do some cleaning up here. Well, greater than 21 is all of those. Okay, so it's going to be 11, 24, 27, 38, 54, 56. If I added all those up, if I did it correctly, right? B, that's A. B. What's the probability that the person chooses does not live with his or her parents? Probability that X doesn't live with their parents. If they don't live with their parents, then that's this right here. So you got a choice. You can add up all 8 of those, or you can add up those 4 on top, these 4, and subtract it from 1. I would rather do that. 0.11 plus 0.13 plus 0.11 plus 0.11, right? 1 minus 33.46, which happens to be 54%. All right, there you have it. All right, we're good.